talk about solutions. Define some terms and describe what we mean by a solution. Solutions are homogeneous mixtures consisting of a solute and a solvent. Okay, what's a solute, what's a solvent? Don't want to put the cart before the horse, but a solvent is the part of the solution with the largest mass. It makes up the majority of mass of the solution. See, we're talking about mass here and not volume. The solute is everything else in the solution. Everything else. And it may be more than one solute. Something to remember is that solutions are not always liquids and solids. Air, the air we breathe, is a solution. Since it's about 72% nitrogen, that makes up the majority of the mass of the air. And the solutes that are dissolved in the nitrogen are oxygen, carbon dioxide, water vapor, and other various gases we have in the atmosphere. So this is an example of a gas in a gas solution. Ten-karat gold. What this means is 10-karat gold means that we have 10 parts gold and 14 parts of something else. So it's not really a percentage, but 24 parts gold out of 24 parts would be pure gold. So that's what the carat thing means. 14 karat gold means it's 14 parts gold and 14 parts something else. So that means that 14 karat gold is 50% gold. So 10 karat gold is the solvent is gold, provided there are more than one solute in there, and usually it's copper and silver. Silver to make it shiny, copper to make it just a little more durable. So this is an example of a solid solution. Another example of a solution is Pepsi. Pepsi is mostly water, so therefore water is the solvent, and solutes are things like carbon dioxide gas, sugar, acid, flavoring, and color. So here we've got a liquid, and we've got gas and solid. We could also have a solution of alcohol. For instance, common disinfectant is 70% ethanol. Now, ethanol here makes up 70% of the solution. So therefore the solvent will be ethanol, and the solute would be water. So what we have is we have a liquid solution. So solutions can be different kinds. Another important property of solution is explaining how much solute is in the solution. And there's three ways we do that, with the volume percent, a mass percent, and molarity. Now the percent of a solution, in this case we were doing alcohol, by volume, is the percent equals the grams solute divided by the milliliters of solvent times 100%. This is a very common measure, particularly in pharmaceuticals, where we're working with liquids primarily, and therefore we're measuring volumes. Mass percent is a little bit different. It's going to be grams of solute divided by grams of solute plus grams of solvent times 100%. And then lastly, molarity is going to be, big M for molarity is moles of solute divided by liters of solvent. And that's all there is to it. No multiplying by 100. Much more handy in doing stoichiometry problems. So let's say we have, we'll make a solution that's a 12% salt, 12% sodium chloride. Let's say we were to do this 3 different ways. So the volume percent volume percent would be percent equals 12 grams of NaCl over 100 milliliters times 100% would equal 12% sodium chloride. But what if we want to do a mass percent? It's going to be a little bit different. In that case, the percent would equal the grams of solute divided by the grams of solute plus the grams of solvent. So in this case, we had 12 grams sodium chloride. Divide that by 12 grams sodium chloride plus 100 grams of water times 100%. So that would be 12 grams sodium chloride divided by 112 grams of solution times 100%. Oh man, I gotta do some long division here. 12.0 grams divided by 112 equals 0.01. Oh no, it'll be 0.1. So 112 divided by, to do subtraction, 8, cross that out, it'll be 8, bring this down, I'll put a 0 up here, and it becomes 80, we're going to need more, 800, so we're going to need like 7 there, 7 times 2 is 4, carry the 1 goes 8, 7, so 734 is going to be a remainder of 66. This is equal to half of that, so that's going to be 5. And then we multiply it by 100, the answer would be 10.08% NaCl. How do you know the difference? Well, we would call this weight to volume, and this would be weight to weight. And then molarity. The molarity of this solution equals moles divided by liters. So how many moles is 12 grams of sodium chloride? So that's 12 grams divided by 58. 58 goes into here twice. So that's 16, carry the 1, just about 0.2 moles. So it's 0.2 divided by 100 milliliters, or 0.1 liters, equals 0.2. 0.2 divided by 0.1, so that's 0.2 times 10 equals 2 molar NaCl. So there are 3 different numbers all representing the same mixture of sodium chloride and water.